There. So this, the reason it says Marshall values is because this is for the amp JVM 410H. This is the EQ. So for the treble, they have a 200 kilo ohm potentiometer, which looks like this is what pots look like for anybody who's not seen anything but a knob. So you have tiny ones here. These are 10K. These are 100K. This is a input on a guitar. So you see this part, and you plug in there, and you're connected to ground and live. Now you can tell as ground is right there, which goes around the body of a quarter inch plug, and this goes in this ring in the center of these orange, comes up here and presses against the tip. And you get some fun pots in this too. So like this is a 500K type A pot, which I believe is the log that goes in a hump. This is a 50K. Also type A. Can't really read it, but that says type AX2. And that means there are 2 gangs. And each group of this is a gang. So this would be used in like a stereo where you need one knob controlling 2 channels. Because if you used one like this, you're mixing down the mono at the pot, which first off is not a good idea, and second, it defeats the purpose of having stereo. So let's get this back in here. And I have 10 1 meg pots, which is 1 million ohms. Those I'll have an audio taper, which swoops up, so it starts off a little bit and increases in an exponential curve. Now, for the reason I have these mapped out is because in this amp I'm making, even though it's based on an LM386, and although it's going to be a small form factor, I want as many features as I can put on it. One of which being a full EQ. So I took first off, the RC time constant I have on the other page. This is the face. This is the face of the cabinet that I'm making for it. So this is the RC time constant. Simple. Time equals resistance times capacitance. So you have your second, your ohm, and your farad. The normal one is FC, which is your frequency, equals 1 over 2 pi RC, or 2 times 1.14 times whatever your resistance is times whatever your capacitance is. And your capacitance is always going to be a very long decimal. And that's because 1 farad is rare, and you'll never see it. You'll never see it in consumer electronics. The closest you'll get is 1 millifarad, and it's, well, no, maybe 4 or 5 millifarad. Because like the biggest value I have is 2200 microfarad, so it's 2.2 milli. So back over here, since I know the frequencies I want, I need to find the resistance or capacitance I need with what I have. So for instance, if I have a 47 picofarad, which is one magnitude, not magnitude, but it's much smaller than this. It's 1/10 that. I should go and do prefixes. So you have your farad, then your millifarad, and your microfarad, nanofarad, picofarad, and femtofarad. Femtofarad is barely ever used, and there aren't many that are made. The ones that are made, I'm pretty sure, are expensive. But you'll see this, you'll usually see these as like 0.5 pico, which is 500 femto. So, when you have all this, and you try and find it for something else, you just replace whatever is outside the division. You replace whatever you need with the value outside. So like, if I want to find resistance, I'm going to find R equals 1 over 2 times 3.14 times whatever frequency I have times capacitance. Now this is only finding the beginning of the range. So like bass, it's at 7 hertz. And this is a guitar amp, it's not a bass amp. So if it maxed at 7 hertz, it would be useless. The only thing you'd be taking out is like some muddiness, and it wouldn't even really be noticeable. But to find the max of this, once you have everything here, your capacitance can be variable. I don't have a variable capacitor, but I do have many variable resistors. More than I showed you even. I should be getting more though. I don't have as many values as I would like. So say I have okay. I want the upper range of the bass to touch or get as close as possible to the mid's beginning as possible. And that's just so I have all the frequencies covered. So what I'll do is have it be R equals, I usually do the bottom first because I don't like to have the one sitting way out here. I like it centered. So I'll have R equals 2 times 3.114 times, let's round that up to 362. 362 times 0.1234567 2345678 and it's very important you have it over 1, otherwise it's a worthless value. So on the calc, it's 1 divided by 2 times 6.14 times, what did I say, 362 times 0.1234567 89. So that would be 20,000 ohms. So I'm gonna put it, I'm gonna redraw that. So I'm gonna make this R superscript B for base equals 19994 ohms. 20 kilo ohms. Now I need to do that for the mid. I want it to touch the treble. So that means replacing the frequency with 1694, and it's still a 22 nanofarad capacitor. So 0.123456789. So I'm going to need R mid to equal 42,727. Oh, I moved the decimal place. Now that would actually be impossible to increase the resistance more than that. That would be like having the pot set to 50%. I guess you can do it, because with this pot, this lug taps the wiper halfway through. So 4272.7. ohms, which is roughly a 5 kilo ohm resistor. Now I'll show you what it's like trying to use all the same value for a resistance. It's a pain in the ass, because that's what I started doing on this side. but I'm actually going to redo them. Because I went with... I originally did this math trying to use the same capacitor. Well, for some of them. And then when I found the frequency, I tried to match that with the others. I shouldn't have done that. Well, I tried to match them to the Marshall schematic. I shouldn't have done that, because I should have been looking for what I need exactly for the capacitance using the frequency that Marshall puts. So I'm going to change out change out capacitance for frequency. So treble, mid, bass. I'll erase these when I get to them. But it looks like it's getting a little dry outside, starting to bleed a bit. So we have capacitance equals 2 times, I'm just going to put pi, times 1000 times 13, no, it was, 1693. Mm-hmm. 69. Nice. So let's plug that into the calculator. That is, oops, forgot the over 1. That's important. So capacitance equals 0.1234 56794. So that would be a 94 nanofarad. I would probably round that up to 100, because you're probably going to get close to that anyway with tolerance. Could also bump that down to an 80 something. You might be able to find like a 90s. Now I do that again for here. Since I have the math here, I can just carry that down. Because the only thing I'm changing is the resistance. So C equals 1, 2, 3, 4, 5, 6, 7, 19 nanofarad. We're already hitting the point where, like, you can find the 20, you can find a 15, you can probably find a 19 somewhere if you look hard enough. But once we drop down to the picos, which would be round about the 10K, I don't think it's going to be exactly half, but it's going to be in the 10k area where you're going to drop to Pico. And even though Marshall uses a 470 Pico, the further down you go, you're going to get a smaller and smaller value. I almost guarantee you the 1 meg is going to be using a femto. Almost guarantee it. Yeah. I was pretty close. 9 nanofarad. Two nanofarad. There are absolutely 2 nanofarad capacitors. Like that. That's an on the package listing standard from whatever company does standards. But then you jump to 100k. And you get 9.4 times 10 to the negative 10th. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 94, 940 picofarad. And you know that because it's each magnitude is in threes. So milli is 10 to the negative third, micro is 10 to the negative sixth, nano is 10 to the negative ninth, pico is 10 to the negative fifth, or negative 12th. Femto is 10 to the negative 15th. I need to get my labels correct. And we double that resistance, and we get 470 picofarad, which checks out because I did use a 200 kilo ohm resistor and a 470 picofarad for treble. So our math is good. Hooray. Big thumb. And we get a 376 picofarad. I don't know about 376, but 370 might exist. 380 almost surely exists. Then we get to 188 picofarad. And 1 million gets us 94 picofarad. So you could absolutely use a 1 meg for treble. Which helps me because I have 10 1 megs. And I would like to use them. Because I also got these nice rubberized knobs for them. Alright, now I'm going to be erasing those. Also, get one of these erasers. It's called a knead eraser. K-N-E-E-D, or K-N-E-A-D, I can't remember. They're for art. I bought these maybe 15 years ago. I'm still using them. No, not 15 years ago. That's way too fucking long. When was I in 7th grade? No, it would have been 2007. So I was close. So 12 years ago. And to make it perfect again, you just tear it apart, put it back together a few times. It sticks really nicely. Although when it's cold, it's a rock. Still does its job, but you can't manipulate it as much. Pain in the ass when you live up here in Indiana. Half the fucking year you can't really use them. I should sit on them. They're not comfortable to sit on. Yeah, my mistake with doing this the original time was trying to make the resistance and capacitance constant, and that gives you a bad time because, well, it gives you numbers that are nice to know, but they're not useful. So it was a waste of time and space. So for 1K, I'm gonna rewrite this. I need the frequency of 361, 361.89, 361.89 times 1,000. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now, we're no longer in pico. We might be in high nano. So that's milli. Yeah, it's 440 nanofarad. This is an 88 nanofarad. And a 44 nanofarad. Nine nanofarad. Any takers? We're gonna get 4.5. 4.5 nanofarad. No, mine truncates it to 4 because of how many spaces it can have, but I know half of 9 is 4.5. Then we get 2.25 nanofarad. What's the deal with this capacitance? was going in half, Jerry. Oh, well then. Give me the same fucking answer between 200 and 250. Okay. So I'm just gonna put it as 2. You're not gonna get exact, but whatever. Now we're getting 2, 3, 4, 5, 6, 7, 8, 9, 88. So that's to the negative 12th. This is the 12th place after the decimal. So 880 picofarad. This I know 1 meg is double that. I know it's probably going to be 440 picofarad, but I'm going to do the math anyway because I'm like that. And I was correct. So it's really nice. This page is going to be finding capacitance. The next page is going to be finding resistance, and I've already found resistance. I've already found it. And that's if I'm using the exact same. Oh no, it's if I'm finding the right frequency. Never mind. So now for bass. Don't you hate it when there's too much pressure and you crinkle? Come on, baby, I'm not doing ASMR here. I'm doing maths. Doing mini maths. You can see my name is Mathis, even though it's not dyslexia. I should note the frequency I'm using for these are the exact values. It's not rounded. I rounded them on the other side for I don't know. 7.23 times 1,000. Ooh, that's a fairly meaty capacitor. So it's 0.12345 2024. So this is going to be 22 microfarad. I'm so used to doing pico, I made the arch. This is a funky U. Fuck. I have a feeling I'm gonna be doing that a lot, so I gotta get it right. Fuck it, close enough. Microfarad. 5 is 0.123456. I'm gonna make sure that lines up better. So at a glance, you can see 3, 4, 5, 6, or 405. That is 4.4 microfarad. That looks better. For 10,000, there's a 2.2 microfarad capacitor. for 50K, it is 1, 2, 3, 4, 5, 6, 7, 8. Oops. Nope, I was right. And 8 would be, it's past 1, 2, 3, that's milli, it's micro, it's 440 nanofarad. And for 100, it's another 6 zeros. 220 nanofarad. And 110 nanofarad. And 88 nanofarad. And 44 and 22 nanofarad. And that makes total sense because on that schematic they use a 22 nanofarad and a 1 meg for the base. So I got it. So for treble, it is 1693.99 hertz. Mid is 361.89 hertz. Base is 7.23 hertz. Well, that's done for now. And hey, it gave me another 45 minutes on the stream. And to think I was thinking about stopping. I've only dropped 359 frames. That's only 6 seconds of 3 3/4 hours. What other math can we do? What other electronics math can we do? You know, a lot of these aren't outside the, like, they're not ridiculous. Like 94 picofarad is a very small number, but it's not unreasonable. I should have known it'd be like that too, like 1 magnitude, because 1,000 to 1 million is 1 order of magnitude. I think. I can't remember if magnitude. I can't remember what the math for magnitude is. Either way. You don't need to know. Well, the capacitance doesn't change. That won't change with frequency. Okay, what we can do. We can design the thing. Holy shit, I actually got the dimensions correct. This is the LM386. Tiny little op amp. And its pins do okay. 1 and 8 are bridged to have tone or gain control. 2 is the non-inverting input. 3 is the inverting input. 4 is ground. 5 is audio output. 6 is power in. 7 is bypass. You can get those for $1 a pop. And these are the pops with the knobs. Now, the one thing that's going to help this sound better, at least louder, is this guy. This thing isn't made anymore. It's a TA7769P. What its job is, let's see if I got that name right. Yes. This thing's job is to drive a radio cassette or TV speakers. So it has 16 pins, because it has to do basically two amplifiers in one. Now there's no gain control on this, but there is two inputs and one output per channel. So there's an inverting and non-inverting input per channel. But what you can do is you take the output of this. So say, I'll get it closer. I don't remember what the inputs on this is, but so you take the output into the input. You can then take that input, or you can take that output into this input, then have another output. So it gets amplified, then amplified, then amplified, then it goes to the speakers. But that's if you're wanting to run one speaker or two in series. And that's fine for 386 and TA7769P. But if you want to run two at once, you're going to run two leads. Come on. You're going to run two leads to this input left and this input right. And then you're going to get the same sound to both channels. And it's all going to go on this tiny little perf board. Not all like hardwired on there, but it's going to be like, you're going to have like wired in like that on the pot, and that's in the front. Oop. It's going to be like wired in like that, and on the, like wherever it needs to be on the front of the cabinet. And I can see that because it's going to look like a discrete head and body, but be combined. considering making them separable. Oh, and this is this is funny. This is an RGB LED where I had to take off the green because I accidentally hit it with 1.9 amps instead of 19 milliamps. Turns out the resistor I picked was yellow, purple, gold, gold instead of yellow, purple, brown, gold. That means it's 4.7 ohms, not 470 ohm. Because LEDs can only take like 20 milliamps. So if you're running it with 9 volts, then you need a 470 to drop it to 19 milliamps. 470 ohm resistor, that is. Like this. Well, this is a 47K. This is yellow, purple, orange. Well, we could either design the circuit now on this, or I can open the program to do it. Or we could save it for another day. We're almost at 4 hours. I'm going to pull up the schematic for the other amp. Well, the pin out. But since I got the dimensions of that perfect, whoops. I'll put this back over here. This nice little IC grabber. There we go. And you'll see during salvage, I broke 2 of the pins. I know that is an output. I think it's an important pin. I know that. See, pin 2. Yeah, pin 2 is an output. GG. And pin 8. Let's see, what is pin 8? Eight's for the bias circuit. Oh, that's convenient. Fits perfectly into 3 squares. You know, place that back on the board then. And I got 10 of them. There's the other 9 right there. And this big honker. This is a LM1876T, which is a 20 amp power, or 20 watt power amp. This thing is going to sound real fucking loud. That came off a sound card from 1998. So this, I'm going to label these two. Let's put a little cutout here. Cutout. .386. TA 7769. P. Now this is going to have here. I need to see what I'm doing on there. This is going to be practice amp I'm just going to have volume. That's volume. What the fuck? It's 2 a.m. What am I talking about? It's gonna have volume, gain, bass, mid, treble. So it's going to have at least 5 knobs. I'm tempted to make it 6. Depending on how it sounds, I'll decide what that 6 is. It might be a treble, mid, or bass boost. Bass might just make it more muddy. Mid might make it sound a bit more like it's in a can. And treble might just make it shrill. I don't know. I'll know when I do it. Hell, I might just put all of them so I can say, fuck it, mine has 9. And what's that last one that makes 10? That would probably be a second volume somewhere. Problem is, I need to pull up the one I got. Okay. This is the one. So what's it rated for? 100 milliwatts. Cool. So 1/10 of a watt. And what is the LM386 rated for? .5 watts. Okay. Never mind. So it's going to have a max of 8. And they all have to be before the preamp. Or before the amp. They have to be in the preamp. Here's 1, 2, 5. That's too narrow. 1, 2, 3, 4. That's too close. There's that. So I have a brand new amp powering a 20-year-old amp. I have a feeling it's going to be fucking loud. Well, age does matter, but combined this is like 3 watts, and my speakers are rated for 5. So it's going to be nice and hot. By that I mean hot signal. Oh, come on, why couldn't I have broken that pin? Pin 1 is non-connection. So I have 2 and 15 being outputs. Alright, so I'm gonna be writing on here for technical stuff. TA7769P pin use. So we have 1 not connected, 2 amp, 2 out, 3 is, it says BB2. I don't know what that means. Okay, now I'm trying to find out what pin 3 is. Oh, you can bypass the internal voltage gain. Okay. I'm probably not going to do that, but cool. That's BS too. Oh, and to make this even louder, for just like with the 386, where you can take the you put it in to the non-inverting, then you take the out and put it back into the inverting, and then it goes back to the out. That increases the volume of the 386, but you can theoretically do the same with this. So you have your inputs of pin 7, 6, 10, and 11. 7 and 10 are the non-inverting. So if you take the output of 15 and put it back into 11, then it'll be louder. Then you take 15 again and put it on 7. Then 7 comes out of 2, 2, bring it back to 6, and then 2 to the speaker. So you effectively get 6 places in this where it's amplified, even though there are technically 3 amplifiers. Hacks. Total hacks. So pin 3 says B S 2. I need to look into what that is. 4 is ground. 5 is also ground. 6 is amp 2 input. So it's amp 2 inverter. 7 amp 2 non invert. Yeah, I'm just gonna write that out. Eight is reference frequency. 9 pre-ground? Or is that preamp ground? It's showing it directly to ground. So 10 is amp 1 non-invert 11 amp 1 invert 12 is ground. 13 is also ground. 14 is BS2. I'm sorry, BS1. 15 is out 1. And 16 is where is pin 16? Ah, that's where the power comes in. So let's label it as BCC. I'm going to do the same for LM36. 1, 2, 3, 4, 5, 6, 7, and 8. It's gain. It's also gain. It's bypass. 6 is 6 is a BCC. I think I need to check that. Yes. 5 is out. 4 is ground. 2 is on invert. 3 is invert. So now we know our pins. And with that, I am over 4 hours. I'm tired. I want to eat a little bit and then relax. So I'll see you guys some other time. Bye.